In this question, we've been asked to sketch a possible graph for a function that adheres to the two properties or conditions set out, and those properties being that the f of 5 does not exist and the limit as x approaches 5 of f of x does not exist. Many of you may end up drawing a function similar to the one I've drawn here, a rational function which has a vertical asymptote at x equals 5. If there's a vertical asymptote at x equals 5, then that means that the f of 5 does not exist. Now, if we take a look at that particular curve and ask ourselves what happens as we approach an x value of 5 from the left, you'll notice that our corresponding y values get larger and larger or approach infinity. As we approach the x value of 5 from the right, you'll notice again that our y values get larger and larger and approach infinity. Since my left and right hand limits do not converge on the same numerical value, we say that the limit does not exist. So this is one possible graph that satisfies those two conditions that are laid out. And this particular type of discontinuity we're dealing with is an infinite discontinuity. Now, there is another acceptable answer that you could give to this question, and I've drawn it here. It's a piecewise function. And if you'll notice, at x equals 5, I've got two little open circles, indicating that the function does not exist at that particular value of x. So f of 5 does not exist. Wow, the first property is adhered to. Now if we examine the limit as x approaches 5 of f of x, you'll notice as we approach from the left and the right, we don't converge on the same numerical value. So that second condition is also satisfied.